The projection is one of the first things you are probably thinking about when implementing a query with Spring Data JPA. This is because the projection defines the entity attributes and the database columns returned by your query. So selecting the right columns is important for your business logic. At the same time, projections are also crucial for the performance of your application and the maintainability of your code. In addition, you need to choose a projection that keeps the overhead as low as possible and provides the data in an easy-to-use structure. Hi, I'm Torben Jansen. In this video, I will show you all the query projections supported by Spring Data JPA and which one you should use. But before we proceed, if you found this channel for the first time and you want to learn how to create your entity mappings with ease, build incredible efficient persistence layers with Hibernate and Spring, and all types of other Java persistence-related stuff, subscribe and click the bell to get new videos every week. And also don't forget to like this video to help me reach a broader audience. Based on JPA's query capabilities, Spring Data JPA gives you several options for defining your use case's perfect projection. You can use a scalar projection that consists of one or more database columns that are returned as an object. This projection provides great performance for the read operation, but it is used rarely. This is because DTO projections offer the same benefits while being much easier to use. You can use a DTO projection which selects a custom set of database columns. It uses them to call a constructor and returns one or more unmanaged objects. This is a great projection if you don't need to change the selected data. You can use an entity projection that selects all database columns mapped by an entity class and returns them as a managed object. Entities are the recommended projection if you want to change the retrieved information. You can use all three projections with Spring Data JPA's derived and custom queries. Spring will provide you with the required boilerplate code. In addition, it also makes DTO projections a lot easier to use and allows you to define the projection returned by a repository method dynamically. Let's take a closer look at them in the IDE. Scalar projections allow you to select entity attributes that you need for your business logic and exclude the rest. That makes this projection a great fit for all read operations if the result wouldn't be returned as an object array. A query result stored in an object array is hard to use. You need to remember at which position you selected a particular entity attribute. Also, you need to cast the element to the correct type. The good news is that you can avoid all of that and define a use case specific projection by using a DTO projection. When using a DTO projection, you tell your persistence provider to map each record of your query result to an unmanaged object. As shown in a previous article, which you will find in the description below, this performs much better than entities if you don't need to change the selected data. And in contrast to scalar value projections, they are also very easy to use. This is because the DTO objects are named and strongly typed. The goal of a DTO class is to provide an efficient and strongly typed representation of the data returned by your query. To achieve that, a DTO class typically only defines a set of attributes, getter and setter methods for each of them, and a constructor that sets all attributes. To use this class as a projection with plain JPA, you need to use a constructor expression in your query. It describes a call of the constructor. It starts with the keyword new, followed by the DTO class's fully qualified class name and a list of constructor parameters. As you can see in the code snippet, you can use this approach in Spring Data JPA's query annotation. Your persistence provider then executes a query that selects the columns mapped by the reference entity attributes and executes the described constructor call. In addition to this, Spring provides a few other options to select a DTO projection. You can use DTO projections in a derived query without a constructor expression. As long as the DTO class has only one constructor and its parameter names match your entity class's attribute names, Spring generates a query with the required constructor expression. This makes the query's definition easier and still provides you with the performance benefits of a query that only selects the required database columns. Instead of defining a class with an all-arguments constructor, you can also use an interface as your DTO projection. As long as your interface only defines getter methods for basic attributes, this is identical to the projection I showed you before. To clarify, for each attribute that you want to use in your projection, your interface needs to provide a getter method. In addition, the name of that method has to be identical to that of a getter method defined on the entity class used in your query. In this example, the author view interface and the author entity define a getFirstName and a getLastName method. When you use the author view interface as a return type in the author repository, Spring Data JPA generates a class that implements the interface. This makes this form of a DTO projection very comfortable to use. And as you can see in the code snippet, the generated SQA statement only selects the columns mapped by the interface. That changes if your interface maps associations to other entities or uses Spring's expression language. To be able to include associations to other entities in your projection, Spring Data JPA needs to use a different approach. It then selects the underlying entities and performs a programmatic mapping. In the following example, the author entity defines a getBooks method that returns a list of all books written by an author. You can tell Spring Data to map that list to a list of bookView objects by adding the method listBookViewGetBooks to the author view interface. When you do that, Spring Data JPA will get the author entity and trigger another query for each author to fetch the associated book entities. This creates an n+1 select issue, which can cause severe performance issues. You can avoid that by providing a custom query using a join fetch clause. In the next step, Spring Data uses the author entity object to instantiate the generated implementation of the author view interface. From a performance point of view, this is the wrong approach. Your query is selecting too many columns and your persistence provider needs to manage another entity object. Because of that, the performance of this projection is worse than the performance of a DTO projection without a mapped association. You can also use Spring's expression language in your interface definition. This enables you to provide an expression that will be processed at runtime to map one or more entity attributes to a DTO attribute. In the above example, Spring will concatenate the book's title and the first name attribute of the associated author to set the attribute book name and author name. Internally, this projection uses the same approach as I explained before. Spring Data JPA fetches the book entity and uses it to perform a programmatic mapping. Entities are the most commonly used projections. The persistence context manages all entities returned by a Spring Data repository. So each change of an attribute will be persisted in the database and you can fetch lazily initialized associations. This creates performance overhead for read operations, but makes entities the optimal projection for all write operations. Entity projections are by far the easiest to use. All standard query methods provided by the Spring Data JPA repository methods return them. And if you define your own repository method, you only need to use the entity class as the return type. Spring Data JPA then uses the mapping provided by the persistence provider. It selects all columns mapped by the entity class and maps each returned record to a managed entity object. You can add a type class parameter to your repository method to use the same query with different projections. This enables you to define the preferred return type in your business code. Depending on the class you provide when you call the repository method, Spring Data JPA uses one of the previously described mechanisms to define the projection and map it. For example, if you provide a DTO class, Spring Data JPA generates a query with a constructor expression. Your persistence provider then selects the required database columns and returns a DTO object. Spring Data JPA supports all three projections defined by the JPA specifications. Entities are the best fit for write operations. Moreover, you should use a class-based DTO projection for read operations. All other forms of projections are better avoided. Scalar value projections are very uncomfortable to use and make your code hard to maintain. Interface-based DTO projections don't perform well because they fetch entities and map them in an additional step. Okay, that's it for today. If you want to learn more about Hibernate, you should join the free member library. It gives you free access to a lot of member-only content like cheat sheets, ebooks, and a free video course. I'll add the link to it to the video description below. And if you liked today's video, please give it a thumbs up and subscribe below. Bye!